Alright, this session we're going to make what's called a wire element Pilotron. It doesn't use any sheet metal in it. It's all made out of wire. This part right here, this kind of blackish looking frame that's not really black, it's glass tubing that's bent into a frame like that, and then the grid is wrapped around it, and then up inside of it is the filament. Okay, and that's all made out of wire in a piece of glass tubing. And then the plate is made of two zigzags of wire which are placed out from the sides of the grid. Okay, and the whole thing's made out of wire, and supposedly it all worked. So we're going to go ahead and we're going to duplicate that, and we'll see how well that really did work back in the 20s. Okay. Alright, the first thing we're going to have to do is some glass work. Okay, the envelope we'll make using some medium thickness glass. Alright, let's get this glass in here, and we'll cut it off with a diamond saw. Okay, don't say anything. Okay, we're just going to lop this off, make the ends clean. Okay. This is 1-to-1 time. That's 1-to-1 time. It's no using the video to make it quicker. That's how fast the diamond saw is. I'm going to make up the envelope, so I need to clean that out a little bit. I need a rag. There we go. And we need a plug in the back. We're going to use a air hose on here. This is the flexible coupling. It rotates. Put our hose on it. And that connects it to the back. Okay, now that makes it to where we can put pressure on here to take care of the end. All right, we need big hole, big torch, big. Okay, first thing we got to do is close the end off. And it's pinched off, okay? Okay. Now, that gives us a nice rounded smooth end. Okay. Now, first thing we're going to do, we're going to pop a hole in the end of this. To do that, we use our pressure hose. Just going to put it a little mouth pressure, and we're going to heat the end of it and pop it out. Okay, I've been doing some other things, so I have to rewarm this thing. It has gotten cooled off. Use this annealing torch here. That looks good. Glasses on. Dum-dum. Flare the end of this a little bit, the small tube. By flaring it, it makes it to where we don't have it close up on us prematurely. Okay? Now I'm going to smooth it out, make it look good. Okay. Okay, that gives us our stem. Next thing we got to do is blow the envelope, and we'll move this back up in the room here. And we need Big Mama again. I'm going to use air pressure into the hose to go ahead and blow it. We want it spare this time, and 2 inches in diameter. looks real good. Okay, these are the large faces. We don't need to stretch it down. It's going into a standard Shaw base, so we don't need to stretch this one down. Okay? Let that cool off, then we'll cut it, and that gives us our envelope. Okay. And there's our envelope. Okay? See, and that fits into a tube base like that. Okay? Next thing we got to do is make our flare for the base. Okay. For doing that, we're going to use a medium-sized tip. Same basic type of tip, but this one's got 5 holes in it instead of the 7 holes. This one's got 7 larger holes, that's the bigger tip, and this one's got 5 smaller holes. Gives a little bit more concentrated heat. This is a standard national handle, and I've just modified it to use swage lock quick connects on it, so I can switch these real quick and easy. Alright. Okay, you can use a pointed carbon tool here. It's just a flat blade made out of carbon. You use that to spread this out. Let me get the base and see if it's big enough. Looks beautiful. Okay, and there's our flare. Let that cool before we touch it. Okay, the next thing we have to do is we have to make up electrodes. Alright, I've got a piece of number 26 wire here, which is what I use for the lead wires. And we take this, I've stretched it to get it straight. And now I'll use a little piece of sandpaper to go ahead and clean the oxide off it. We want the wire to be shiny. So I'm just going to take sandpaper and draw it down the wire. And that leaves it nice and shiny. Okay, we're going to cut it into about 3-inch lengths. It's not critical. This is just what's going to stick out the back of the tube to solder to the pins in the socket, in the plug. Okay, and we'll make 4 of them. Okay, now for up inside the tube, we're going to use nickel wire. Okay, once again, the nickel wire, this wire was stretched, and that makes it perfectly straight. And we'll take sandpaper and we're just going to clean it. Okay, it's just shiny as can be. Now for up inside the tube, alright, we're going to need They're not going to be very long. It looks like about it's going to come up and it's going to bend over about 1 inch. So we're going to need about 1 inch up in the tube, so we're going to make them 2 inches long just to make sure. Okay, I'm just going to lop. Okay, now we're going to have to make a tungsten junction because we have to have the tungsten in the Pyrex to seal. So we have to go between the nickel and the copper with tungsten. Okay? To solder copper onto tungsten, we have to have a nickel, kind of a welding metal. So what we do is we take nickel tubing. The diameter, the ID of the tubing is the size of the wire, and we place that over the wire, which is quite a trick. Very, very delicate. Okay? I don't know if that shows in the camera or not. Let me see if I can get a close-up of that and show you what it really looks like. Okay, see, we have that nickel tubing. We have that nickel tubing, and we put it over the copper. It's a 1-to-1 fit. It just barely fits over it. Okay, I'm going to take it on the diamond saw and I'm going to cut it off to where it's about 1/16 of an inch. Okay? There it is. Now, it's very difficult to hold a wire up against a curved surface, a round surface. So what we're going to do is we're going to take a pliers and we're going to squish it. I'm going to take the wire and we'll go into here. I'm just going to squish a little bit. See how we flattened it? Now, it's very easy to hold a piece of tungsten wire against there when we do the weld. When you have two round surfaces, you're trying to hold them together, it is not going to work. It is definitely not going to work. All right, I'm going to go ahead and make up 3 more of them. Okay, now we have to do the same thing to the nickel pieces. Simply grab it, squeeze. See how it flattens it out a little bit? Maybe a little more. Okay. Alright, next thing we do is we weld the tungsten onto it. Okay, we're going to use 9mm tungsten. Okay, this is 9mm tungsten here. And I have to have eyeball, I can't see. Alright. Okay, and then we cut it off. We make each one about 1/4 of an inch left over, okay? Okay, that gives us our piece of tungsten welded to the nickel. Okay, now we're going to go ahead and weld the tungsten onto can't do it. Have to go this way. Okay, I increase the power to 120 amps. To melt copper, we have to have a little bit more current, otherwise it doesn't make a good melt. And there you can see. That's the electrode. See, this point in the middle is where the glass seals onto the tungsten. And then we have the flexible wire extending out the back. That's what we solder to the tube socket or tube plug. And then this part, the nickel, is what's up inside the tube to hold the elements. Okay? Okay, so what we're going to have, we'll have the pinch, and we'll have wires coming up inside. So we'll make the two center ones the filament. So that'll be filament, and we'll make one outside one the grid, and the other one the plate. Okay, now we've got two ends on the plate, so we really need to have two wires. So instead of just putting 4, we'll go ahead and we'll put 5. We'll put one in the middle with no connection at all for a plate, and then we'll put filament, and then plate and grid, or whatever. Okay, that way we will have a wire. We'll bend one of them one way, one of them the other way to hold the two ends of the plate. Okay, then up at the top we have to put the connection to hold the cross piece. Okay, and that'll connect the two plates together. All right, and then in the center we have to have the two for the filament that's going to come up in there. Okay, to hold the wires while we're doing the pinch, we use just plain old aluminum duct tape. Okay, we're putting a live. Alive. Okay. A dead. And then and alive and alive. Pinch that over. Okay, now that'll hold them in place while we're doing the actual glass work. Alright, now first thing we have to do is pinch it down a little bit to get it flat to where we're ready to do the pinch. Okay, we're going to use a piece of carbon. We have a piece of flat carbon that will go up inside there, and then we'll pinch it down on it. Okay, the first thing we have to do, heat it up to red hot. For that we use a crossfire torch. We heat it from both sides. Do a little preheat first so we don't crack anything. Okay, it's starting to turn red. Okay, what I'm going to do is I'm just going to up in there like that, and then I'm going to take the squishers and I'm going to heat it. So I'm heating both sides now at once. It's much easier to do that way. Okay, now we got a flat area where we're going to make the pinch. Okay, we pull that out of there. Okay. Now, you don't do something stupid and grab that with your fingers. Boy, that thing is hot. Okay, now, next thing we got to do is we got to put our wires in there, our electrodes. Bend that a little so it'll clear. Okay. Alright. Then we'll clamp these into here. Okay, see, and everything is held. Okay, and we can just move that up in there like so, and then we use our squishers to just squish it down on there and make the connection. And that puts our nickel wires up inside and our connections for the base on the outside. Okay. Over here. Now, to keep from burning these wires in half, I'm going to hold the pincher on there, and then I'm going to heat. Okay, now I'm going to squish it down and catch it. Okay, now I'm going to do the actual seal. Okay, that's the seal. I'm just cleaning up the outer edge right now. Push that glass back in a little bit, make it look better. Alright. That looks pretty good, actually. I'm going to go ahead and fill it in anyway. This outer wire doesn't have much glass holding it. So what I'm going to do is I'm going to just take this and I'm going to just weld it in. I'm just going in there and just putting some glass on there so that it hold in there better. Okay? Just like welding metal, but we're doing it with glass. Okay? So now that outer wire is completely molded into glass and it won't let loose. Okay, now we just go ahead and we're going to just anneal it just a little bit. That's good enough. That's all it takes. That's going to be ready to put the elements on. That's our pinch. Alright, the next thing we have to do, we have to make our grid support, which is made out of some glass tubing. We've got some, not tubing, but rod. We've got some glass rod here, and we have a mandrel made out of carbon. That's the size of the inside that we want. And what we're going to do is we're just going to heat it up and bend it around that mandrel, and that should make us a fairly nice looking piece. We could do it just freehand, but it's easier to do it around a mandrel to get a good square shape. We'll see what happens. I haven't done this before, so we'll just have to see. Alright, to do this we're going to use our small torch. Now what I have is a little slot cut here, and that will hold the start, and that makes it where I can just heat it and then bend it around. Alright, well, here goes. Okay, that looks very good. A little bit difficult there. Okay. See, there we go. Okay, it's all in line and everything, sorta. Okay, next we, okay, we'll make the final bend. Okay, and there's our grid support. Okay. Now, the next thing we have to do before we do anything is we got to make sure we can get our filament support in there. Don't know exactly how we're going to do that. Okay, I got to let this cool a little bit. I don't want to burn my fingers. Okay, the next thing we're going to do, the two ends that went together, we need to seal together. Okay. All right. Now, we have to have two wires in here on the bottom for the bottoms of the filament and one wire on the top for the filament support. That goes inside. We have to get that done before we wind the grid on it. Okay, to do that, we're going to take this piece of wire and we're going to press it into the glass. And we got another one which we'll press on the other side. And then we put another one in the top for supporting it. Alright, let's see what we can do here. Alright, first we have to, this is a carbon block. I don't know what the hell that liquid is. See if we can do this. I don't know. Glass over it. Okay. Okay. Okay, that's on there. Okay, that's the two filament supports, connections. Okay, now on the other side, we need this filament support. And I'm going to take a little piece and put a little dab on there. Okay. Okay, now what we'll do, see, we're going to be wrapping the grid around that. So we need little grooves in it so that they don't move on the glass. The glass is really slick. So I'm going to make just very fine little grooves in there with a diamond saw. We just got little grooves in there. Okay, and that'll make it to where we can wrap that wire around there and it won't slide and move position. Okay, now what we're going to do next, we have to weld in the filament. And for that we're using 2% thoriated tungsten wire. Okay, and for that we go low and maximum. Okay, that's on there. Now I have to take that and put it through the loop up on the top. Which may or may not be possible. Okay, it's through. Bring it back around. Okay, and then we'll grab it, bend it. Okay. That looks extremely good. Now if I can get it welded, oh, it's on there. Okay, and then cut the end off. Okay. See? Okay. That's our filament. Right. The next thing we have to do is put our support on the top for the plate. See, we've got this support that goes across here. We have to have a blob of glass up on the top, and we put a piece of wire across there, and that's going to hold our plate. Alright, what I'm going to do is take this piece of tubing, and I'm going to stick it on the top here, and then cut it off and stick the wire into it. So it would already be cracked. Alright, now I'm going to remove the top part of it. Okay. Now I'm going to flatten it just a little bit. Okay. Next I need a piece of wire to go across there. Okay, got a piece of stainless steel wire here, and I'm just going to go right into there. I'm going to heat it and squish it down into it. See, I burned it off. Okay. Go again. We can do it. This stuff melts instantly. It's a low melting point, so I can't hit it with a torch or it's over with. Okay, got to put some glass over the top. Hold it. Alright. Isn't that something? Okay, now for the grid, I'm going to use 8mm stainless steel wire. Okay, I've wrapped it around one of the ends and twisted it to hold it. to secure it. And I'm going to just take this and I'm going to start wrapping it around. Okay. I'll put it in a groove. Okay. Second groove. If I let loose, it's going to just spring like a bunch of loose spring. Not going to be worth anything. Okay. I'm just putting it in these grooves that were ground with the diamond saw. They're not really evenly spaced, but since this is just experimental tube, it isn't that big a deal. It doesn't matter. The actual spacing of the damn grids really doesn't matter that much. If they're reasonably close, it'll be the same. The only time you're really concerned with it is when you're doing tube matching and stuff like that. But when you're making an experimental tube, oh goodness, just do anything that works. I mean, just to make something that works is so much of a miracle. Okay, see how it's going? This tied off up on the top without losing control of it. Okay, first I'm going to cut it. Cut it off. Well, okay, and then I'm going to wrap it through some. Oh, damn! Oh, I caught this filament with it. Oh, God! Oh my gosh. I didn't break it, but boy, that sure pisses me off. Oh my God, does it piss me off. Do stupid things like that. Now, I'm going to take this and go through and try to tie a knot in it. There we go. Ooh, look at that. See, we're pulling a knot on there. Now, I'm going to have to go through to see if I can get through here. Okay. Okay, and there's how our you see how that filament in there is pulled over the side. When I stuck that through, it caught the filament. When I pulled it, it yanked it. It didn't break, though. It's just pretty tough wire. Oh, goodness, that makes me mad when I do dumb things like that. Okay, there it is. All right, now we're going to weld the assembly onto the base. That is good. Okay, go around the other way. Okay. All right. It's on there. It's on there. Okay. Next, we have to cut those two wires. Okay, we take the grid, go around here. Okay, now I'm going to cut the current. Thin wire there. Okay. Okay, now that gets us the whole assembly. Hopefully it's going to fit up inside here. Okay, isn't that beautiful? That's going to do just gorgeous. All right, the next thing to do, we have to make the plates, the two zigzag wire plates. All right, now the plates, We're going to make out a steel wire, stainless steel wire. We're going to smooth it out. It's straightened out the same as we did before. We're going to take it and sand it. These plates have got, let's see, 1, 2, 3, 4, 5, 6, 7 zigzags in them. I don't know if I got enough wire here. I'll have to get some more maybe. Okay, about that wide. Okay, I'm just going to bend it. Here. All right, one more. Okay. All right, I got to hold that. Okay. Now I'm going to take it around like that. Okay, a little more. Okay, and then now we'll catch the top, hopefully. That looks good. Okay. And we take the snips. All right, that's one of them. All right. Okay. Okay, hit it again. All right. I don't think this one did good. I'm going to do it again. Did good that time. Okay. And there's the tube. All right. Now I want to just examine it very carefully to make sure that the elements are not touching each other. Okay, and this should fit up inside without any trouble. Oh, look at that. That's just perfect, huh? Absolutely perfect. All right, now I'm going to need a little more power, okay? Set the power up on the flasher. Okay, here goes. That's under. That ain't going to break off there. It broke off before, but it won't now. Okay, and this fits up inside there like that. Okay, that will do just fine. Okay, the next thing to do is to seal it together. Okay, we have the tube in the lathe. We've got the blow hose on it so we can put pressure inside the tube when we need it. And what we're going to do is we're going to seal the base onto the tube. Okay, to do that we will use the small tip, small torch. Okay, first we're going to warm the tube up a little using the annealing torch. We don't want to crack anything. Very unlikely to crack with Pyrex, but if you just slam it to it, it can happen. Alright, now we just heat this up. Alright, that's pretty good. We'll go ahead and touch it on there. Okay. Alright, that's perfect. Alright, now I'm just going to go around there and seal it together. Using a carbon tool here to push it up, push the glass up together, and then just heating it to where it fuses. Alright, now what I'm going to do is go around it, make pressure, just to puff it out a little bit, make it to where it won't crack. Okay, that's it. Okay, now we're going to just go a little bit of anneal on it, just a little bit. Doesn't take a lot of annealing on the Pyrex. You just have to let it all cool down. Okay, that's it. All right, and we go ahead and open the valve. Okay, we tested it for leaks using the high voltage device. No blue glow at all, we're good. If there was a leak, there would be blue glow in there from the high frequency. Alright, now we're going to heat this up using the annealing torch to drive the water out of it. Okay, that's good enough, because we're going to put it in the oven and we're going to bake it for hours. Alright, we've got the oven on it. The tube is in the oven and the oven heats up to 900 degrees. And we're just going to let it sit in there for several hours and then we'll seal it off. Okay, we've been baking for 3 hours. I've already cooled it off. It takes about 30 minutes to cool it off. Okay, we're going to remove the oven and we're going to fire the tube up and see how it works. Okay, now we hook our filaments to the two inside ones. You can see it starting to light up. Alright, give it a little more filament. Okay, now the plate. I can't see anything without glasses. Okay, this side over here is the grid. And the other side is the plate. Alright. That should be enough. There we go. Taking hundreds of volts. Okay, we're running at 300 volts. Getting current of about 3 milliamps. And a little more filament. Okay. So, we're running 300 volts on the plate and about 2.5 volts on the filament. We have a plate current of 4 milliamps and a transconductance of just over 100, about 120. So the tube is working quite well. High voltage, it's taking high voltage to make it work because the spacing between the plate and the filament is great. It's quite large. Okay? Turn it off. Even with fairly low filament voltage, we're getting about 1 milliamp of emission. But when we cut that voltage down, well, we're getting it. Okay, that's 90 volts. Let's see what we get with 90 volts. Okay, with our 2.5 volts, we're getting about maybe a 45 emission, transconductance, but we don't get much plate current. It takes that voltage to bring that current up and get the transconductance. Okay, so the tube is a success. Okay, now here we have the getter flasher, and we're just going to go ahead and first warm it up What we're doing is we're driving the gas out of the getter. We're not heating it to the flash point yet. The pump is pumping the gas out. We're still hooked to the vacuum pump. Okay, here goes. Well, that's all she's going to do. She'll get that thing off of there. Softening the glass up, letting the vacuum pull it in. Okay? There it is. Okay, there's our tube. Okay, the next thing to do, put the base on it. We stick the base on using a shoe glue. It's a rubbery glue. It doesn't harden all the way. It turns into a very springy, rubbery material that has no tendency to crack the glass. If you use something hard like epoxy, it's possible that for heat expansion could crack the glass. But by using this rubber stuff, there's no problem at all. It's just beautiful. Okay, and that gets our pins soldered. Okay, we just clip off the extra. Okay, turn it on, and then we get some glowing. Okay, and if we turn the voltage up, there it is. Look at that. Look at that, boy. We were getting transconductance up in the hundreds and hundreds. It's because the getter lowers the vacuum. The vacuum becomes even better and better. Look at that. That's with 67 volts. Wow, that works great. That works really good. Okay. What you meowing about? What you meowing about? You want to be in the picture? Huh? You want to be in the picture? Yeah, she helped me out there. Look at that transconductance. So we're getting transconductance up there at 300 with 67 volts. Well, 400 with 67 volts. That's very good. Okay, that is a complete success.